Hi everyone, welcome to this Rotary Encoder crash course. So this video will show you how to connect and use the Rotary Encoder. So the one we have in our kits is called a KY-040 Rotary Encoder, and it looks like this. So it's just essentially like a knob that turns. Actually also has a button that works just like a normal switch and uses the center pin over there called SW. I'm not going to talk about that in this tutorial because it's fairly straightforward. If you know how to use a switch, you would just plug that in there you would also need the ground, and you could just read that as a digital input. So, and pushing this would trigger it. We're much more interested in what happens when you turn this one. And this rotary encoder is a quadrature encoder, so it actually has the ability to tell if you're going in a forward direction or in a reverse direction. So looking at the pins over here, the first pin is the clock, the second pin is data, then the third is a switch, the fourth is your positive or your VCC or your power, and the last one is ground. So I have them as green, blue, purple, and gray. You can use any color, but be careful with ground and especially power. To if you have a red and a black, use those. I didn't for this one, so I just use kind of colors that remind me of red and black. So as long as you keep them straight, it's all good. All right, so this is a bit hard to see, but I've gone ahead and I've plugged power into this red pin here, ground into this black pin here, and then I've got clock on A0 and data on A1 right next to it. So the A ports are actually analog, I believe input ports, but they can also double up as just normal digital inputs or outputs. So even though they're called A for analog, they're actually also digital. So that wiring should be good enough to let us use this encoder, and these pins are actually also free on your LGU by default. So A0, 1, 2, and 3 I believe are free. 4 and 5 are taken up by I think the ultrasonic sensor. So and most other pins are taken up. So this is a good set to use. So let's go and look at some code. So I'm going to create a new project. New project, and we'll call this Rotary Encoder. And we're going to open it. Actually, it is open. Just go to code. There you go. So then they've got this sample code, which I'm going to delete, and we'll start from scratch. So the first thing we want to do is define our hardware. So I have a rotary encoder clock, which is on pin A0. I have a rotary encoder data, which is on A1, and this A0 and A1 are defined within Arduino itself, so it probably actually corresponds to some number. And then we could also define the rotary encoder switch if we had that in here, and I would probably plug it into A2. We're not going to do that, but that's where you would put it. All right, so let's go into the setup function. And as usual, we're going to begin with serial begin, and we're going to set it to 115.2, so 115,200 bits per second for the serial port. And then I like to print a little intro to say that my program is running. So let's call this a rotary encoder test, and I'll call it V1. That way, if I'm not sure my code is actually taking, I can change this to V2, and then if I see the port, the monitor printing out V2, then I know my code uploaded properly. So it's a good way to confirm that. Also need to configure some pin modes. So let's start with the clock, and that's going to be an input because we're reading the clock and the data. I'll explain why there's 2-second data like that. And then we want, yeah, that's it. So there, that's our hardware. Now the reason there are two signals is because the rotary encoder has um, two kind of internal sensors that help it determine whether it's moving in a forward direction or whether it's moving in a backwards direction. And if you were to look up the data sheet for this KY-040, let's see if I can bring it up here. Yes. Okay. So if you scroll down on the data sheet, it does talk about the basics. So if you want to know more about this, but essentially what it is, A and B are clock and data. And so as you turn this encoder, if you're turning it clockwise, what you're going to get is this hole essentially is moving forward. And so sensor A will see the hole, and then sensor B will see the hole. If you're moving counterclockwise, or like moving this hole, you'll see that sensor B first sees the hole and then sensor A sees the hole. So that's the idea, is that you're kind of looking at these fast enough to know which one turns first. So once you look at A, is it already what B is seeing, or is A different than B? In which case the pin is kind of halfway in and going towards B. So that's the general gist of it. It's a little confusing unless you really read into it, but take my word for it. The combination of two sensors lets you determine not only the count, but what direction the encoder is going in. So that's why we use two signals instead of one. If you were to ignore data, so if you only had one pin available, you could work the encoder with just clock, but then it wouldn't know what the direction is. You'd be looking just like that beam break sensor is when you use it as an encoder. And then you'd have to know some other way which direction you're going. Maybe you don't care, or maybe it's for your motors or for a mechanism, and you've already set the direction on it for the motor, and so you know which direction it is, and you can tell it so that it counts properly. All right, so the hardware is set up. Now we need a loop. Okay, and so what we're wanting to do is we're wanting to read the current state. So let's just use a bool. You can use an int also, but bool should work. So the current clock state is equal, and we're going to read our pin. So digital read rotary clock. Okay, so we're just going to pull that information out. And now we're going to do if the current clock state has changed, because we don't want to do anything until it's changed. So let's call this last clock state, like that. And now we need to, this is a variable that needs to be saved from one loop to the other. So let's go make this as a global variable. So that's going to be last, sorry, clock state. And let's initialize it to false. That's not a Boolean. There we go. Okay, so now we have that. Now don't make the mistake of forgetting to update your last state. So this is no longer, the last state is no longer what it was. So we can either say, hey, now it's equal to current state, or because it's a Boolean, you can actually just toggle it. So you can actually say like that, or you can just say, well, the last state is equal to the last state for next time is equal to the current state for this time. So the next time we go through this loop, we want last state to be the current state. So with that done, now we know something's changed. So we either have to increment or decrement our encoder ticks. So we don't actually have an encoder tick variable yet. So let's do that. Encoder ticks. Let's start that at 0. Okay, so that's going to be what we keep track of how far we've gone for, or how far we've turned for. So let's go here. So then what we want to do is use that second sensor. So if, and we're going to do a digital read of the rotary encoder data. So if that is equal to the current clock state, okay, so whoops, I missed bracket. Because we're saying if the data pin or the data sensor is reading the same thing as the clock sensor, that means the data sensor went first, right? So the data sensor tripped, and now we're looking at the clock. So if that's the case, we know we're going, and it's either going to be clockwise or counterclockwise. It's a little hard to tell based on until you try it. but I believe that in this rotary encoder's case, it does mean clockwise. And if it's reversed, then just change it. So what I'm going to do is I'm going to increment the encoder ticks. And maybe I want to know if I'm going clockwise or not. So let's maybe save that information. And we're going to say that clockwise equals true. And we're going to set that up as a global variable too, like that. Yeah, doesn't really matter what we initialize it to. It'll get fixed on the first pass. Okay, so if it's not that, else, then we know that our encoder ticks are actually going to go down because we're counting backwards, and clockwise is equal to false because we're going clockwise, counterclockwise. All right, so I save the state, and now I'm checking whether I should tick up or tick down. All right, and then what we can also do is we can print that something happened. So if we did go into this, then we're just going to print the tick. So let's say yep. So if it's changed, we're going to do a serial print line, and we're going to print encoder ticks. Encoder ticks. We could also print the whether it's clockwise or not, but we can tell that by if the encoder tick's going up or down. Okay. So now is my robot on? No, it is not. Turn the robot on. Like that. And let's see if we got this right. So first we can compile it and make sure we didn't make any obvious mistakes. For example, that. So I should not have closed that right away. Go back to program. So it's saying that in function void loop, there's a bracketing issue. So either here or before it. If current, I missed it again. Come back, which line? Line 21. So down here. Yes, I've got 2 instead of 1. There you go. Build again. All right, so it's good. Now let's attempt to program that. All right, so it's not responding, so I will be right back once I fix that. All right, so I reloaded this page after timed out. I reselected my serial port, which is the TCP2 and then the program worked. So let's look at the monitor. So it's got a rotary encoder. It had one initial number. Now let's see if I go and I just turn it. Yes, there we go. So if I'm turning it clockwise, it is in fact increasing, so that means that's correct. And if I go counterclockwise, it is now decrementing, and it'll even go into negative numbers. So up, down, and so on. So there you go. That is the rotary encoder. Make sure it doesn't slip out. One important thing about encoders is that it's really important that you read them in time. If your program is doing a lot of stuff between times it checks, so in this case, I'm just going through a loop. If there's a lot going on here, you may miss a tick. If that happens to you, you may need to look into interrupt methods to do this. So an interrupt is essentially a function that gets called or something that happens and calls one of your functions and will interrupt the processor. So even if you're in the middle of doing something else, it'll go call that function, do what it has to do, and then come back to your program. So it interrupts it in the middle. You want your interrupts to be very fast, so you don't want to do too much in there, because if you do too much, you may cause the rest of your program to break. So that's more of an advanced topic. There are examples written that are currently on our Google Drive to be shared. They hopefully will end up on the website in not too long. Or you can just post a question to our Discord help channel, and we can point you in the right direction for using interrupts. So they are more complicated that they are more reliable, and it's up to you to decide if you need them or not. So yes, that's about it. So hopefully this tutorial was useful, and we will try and do some more for other pieces of hardware. Thank you.